So, okay, we're done with beaches. The next feature of coastal deposition that we want to take a look at are sand spits. Sand spits, there's no L there. For some reason everybody thinks they're called sand splits, but no, they're not. Right, sorry, just getting comfy here. So a sand spit is basically a long, narrow ridge of sand that's attached to the coast at one end and goes out to the sea at the other end. And again, these are a feature of deposition. The main processes involved in their formation are longshore drift and constructive waves, which lead to deposition of material. So they come in all shapes or sizes, but in general, at one end they're attached to the coast, and at the other end they go out to sea, and they're made of sand, and they tend to be narrow. They also tend to curve at the end, and we'll talk about that in a minute. As they build up over time, they can support construction. So you can see here's a sand spit that's got roads, got apartments on it, golf courses on it, etc. And again, just note that the end of this is curved inwards. So this is called a recurved lateral, and these are quite common on these as well. Now, is that going to stay there forever? No. Okay, just there. Right, sand spits in Dublin. You should be able to see two sand spits here. So we've got Dublin Bay, Howth Head and Bray on one side, and here we have Diamond Beach, also known as Bull Island, and that's a sand spit. And just over here we have Portmarnock, and that's a sand spit. So very common around the Irish coastline as well. Okay, can I get rid of these things? Hang on, discard. Sorry, these are just annoying me. Let's go back to this. So how do they form? And again, I'm going to start drawing all over this. So if we start from this point over here, okay, you see me? The material is being carried along the shore in this direction because of longshore drift. So swash, backwash, and it's going in that direction because of the wind. Now, when it gets to an obstacle, and that obstacle is anything that prevents longshore drift from continuing. So, for example here, this is the coastline, and the coastline changes shape, okay? Longshore drift isn't able to turn the corner. So at X here, there's a change in the shape of the land. So longshore drift will continue, but it doesn't go around, it can't go into the bay. So what it does is, it just goes this way. And instead of depositing material along the coast, it now starts to deposit the material out at sea. So at the bottom of the sea there, you have material building up. And longshore drift continues, and more material builds up. And eventually all of that material builds up until it's above sea level, and you can actually see it. So longshore drift happens because there's an interruption to longshore drift. At the start, the material is deposited on the seabed beneath the water and you can't see it. But so long as longshore drift continues, this keeps bringing material. And this material builds up and up and up, and the sand spit will continue to grow, and with repeated deposition, the material will build up and eventually be visible above seawater. And then what happens is, we've got the first stage of the spit. Longshore drift will continue against that. So swash, backwash, and all of a sudden there's another interruption. More material will build out at sea here. It will eventually be above sea level, and that will result in the formation of the spit. And over time what happens is that the sand spit will grow longer, and it will keep growing and growing and growing until we look at what happens next. As I said to you earlier, they tend to curve towards the shoreline. So at their ends, their tip is curved back inwards, and this is known as a recurved lateral. And this can be caused by two things. It can be caused by wave refraction because the waves are bending them in, or it can also be caused by the prevailing winds. But just to note that that's called a recurved lateral. It sometimes comes up in short questions. Anything else we want to talk about there? Oh yeah, the area behind it. Okay, so here's your sand spit, and eventually say it's gone this big here. The sea can no longer have easy access in and out, okay, because it's now being blocked by the sand spit. And what happens is that there's only a narrow channel that the sea can get in through now. So the sea cannot remove all of the material that's building up behind the sandspit. So you have much lower energy waves in here than you do out here, because only a small bit of the sea is able to get in. So in the area between the sandspit and the coast, access is being cut off to the sea. So you've got very low energy waves, so mostly deposition. And what happens here is that material will build up to form something called a salt marsh. And this is basically a shallow area of water that becomes filled in with sediment. And eventually they can build up and up until it's actually land again. A good example of this is if you can picture Clontarf and Bull Island out. So say you're driving towards Howth and you've got St. Anne's Park on the left hand side and you've got Bull Island on the right hand side. When the tide is out, all of that area there is devoid of seawater. There's no seawater there, but that's a salt marsh. But when the tide is in, you get a low amount of seawater there as well. So the salt marsh forms behind the lagoon. More pictures, and this is a really good example of a recurved lateral where the end is curved back in towards the shore, and you'll also see that this has been colonized with grass. So what happens is you tend to get sand dunes at the back of the sandspit, and they're colonized by marrow grass, and this stabilizes the entire thing so it doesn't blow away. And just wanted to point out two words here. This is the seaward side, because that's in your note, and this is the landward side. Okay, and you'll also see something similar to this in Bull Island. So the beach on Bull Island is Dollymount Beach, and that's backed by the golf courses, and then there's dunes all in the middle of them. So it's a fairly permanent structure, and a lot of that is because the marrow grass has stabilized it. I was going to get you to draw this diagram, but I just redrew it myself there, and I think this is probably a little bit more straightforward and easier to understand. So this goes on to page 16 of your notes down the bottom there. I hope you can read my writing. Let me know if you can't. Right, how do you recognise them on OS maps? So basically, long ridge of sand protruding out, and in this case here there's sand dunes on it, and it's got a recurved lateral. Okay, so it's bending back in towards us. The yellow indicates that it's a beach. Again here on Tramore, if you're familiar with Waterford, sandspit coming across here, and what's happening, and you see the change in colour. So this is a darker blue, this is a lighter blue. So this means that this is a salt marsh in beyond here, because this is the only point of access for the sea. So very low energy waves in back here, so you'll have a salt marsh forming there. This is Ross B Creek, sandspit, recurved lateral, and again you'll see the different colour in the water there, indicating a salt marsh is forming. And this is Portmarnock. The tip is curving in towards, this is the seaward side, this is the landward side, and again you'll see between the sandspit and between the land, it's starting to become infilled with sediments. So that area there is the salt marsh, and that's because only a limited amount of water can get in and out, and therefore it's been filled in with sediments. I think I'll just continue on with this. So these are features associated with sandspits, and these are known as sandbars. And a sandbar is basically, it can form out at sea. Let's just get through all of this. Okay. There's two ways these can form. An offshore bar is this one here. Okay. And this is basically a ridge of sand or shingle or any other material that's deposited in the sea parallel to the shore. And basically they can move inwards. So the action of the tide can move the shore inwards. If this then blocks off a bay, it becomes known as a bay mouth bar. Okay, so in A, you've got the offshore bar, it's still off the coast. In B, the offshore bar has moved in to block off the bay, and it's now known as a bay mouth bar because it's a bar that's across the mouth of a bay. The area behind it now is completely closed off, and when this is completely closed off, you'll get a saltwater lake called a lagoon. So it's no access to any source of water, and it will eventually dry up. So this is salt water blocked off. So salt water here blocked off by the sea. Saltwater lake that's enclosed is known as a lagoon. It will eventually dry up and become a marsh. So that's one way they can form. The second way they can form is that we have a sandspit forming here. And the reason why the sandspit is forming here is because there's a change in the direction of the coastline. This sandspit will keep growing, and eventually, if we go down to B, the sandspit can grow across the mouth of the bay, and this then forms a bay mouth bar. And exactly the same, you've got the lagoon behind it. So bay mouth bars are basically when a bay has been cut off by a ridge of sand. That ridge of sand could have originally been an offshore bar, or it could have originally been a sandspit. Okay, so ridges of sand and shingle, you can read that in your own time, it's in your notes, and a good example of this is Wexford Harbour. Bay mouth bars, ridges of sand or shingle that enclose a bay. It can be formed by offshore bars or sandspit. An example is Ladies Island in Wexford. A lagoon then was once a bay, but has been cut off from the sea by a bar, and it may gradually be infilled by deposition. And the example is Ladies Island Lake in Wexford. The last feature associated with this are tombolos. And a tombolo is basically an island that's connected to the shore by a sandspit. So this is the island here, okay, here is the shore, and the sandspit has grown and it's now connecting the island to the shore. And if you think about Dublin, Howth Head or Sutton is a tombolo that connects Howth to the shoreline. So that area is Sutton. If you're familiar with Sutton Cross, you'll know where I'm talking about. And these can be formed in one or two ways. They can be formed by wave refraction. So this has come up a lot. So a piece of land jutting out into the sea, it will cause the waves to concentrate their energy on that piece of land, which means the other waves that are coming in here are very low energy waves. And if they're low energy waves, then this tends to result in deposition, which will form the ridge of sand connecting the island to the shore. They can also be formed by the normal way if there's an interruption to longshore drift. So a tombolo is formed when sandspit connects an island to the mainland. They can be made up of stone, shingle or sand. And an example, Sutton joins Howth to the mainland there. How do you recognise these on OS maps? Well, the clue here is that this is Oa Island, but it's now connected to the land, so that must be a tombolo. And there you can see it, so that's the satellite image of it, and it's almost closed off. So we've got a salt marsh in here behind it. This is Tramore again. It's very, very close to becoming a baymouth bar at the moment. This is still a sandspit, but if it goes over any further, this will be a baymouth bar, and this will be a lagoon. So baymouth bar would beach on the seaward side, and you can see here in the satellite image a huge amount of sediment being infilled behind that sandspit. This is Ladies Island Lake in Wexford. And in this case here, the offshore bar or the sandspit has completely closed off the water behind it. So this will be salt water, mostly originally. Now there are some rivers, so it could be a mixture. But this is the lagoon, okay? And this may become filled in over time and will disappear. So lagoon there and the baymouth bar in front there. Another good example of a lagoon in here and the baymouth bar out the front here. So in this picture we have lots of stuff going on. We've got sandspits, Bull Island, sandspit at Portmarnock. We have the tombolo of Sutton connecting Howth to the mainland, and you can see we've got salt marshes in behind both of these, so not quite lagoons just yet. This one here I just wanted to show you because this is Shenix Island off the coast of Skerries, and what you can see here is that it's starting to grow a little sandspit, and eventually this will connect it to the land and this will become a tombolo as well. Okay, so it's a growing tombolo and you can see it there. Okay, so that's a satellite image of that island, that's Shenix Island. You can also see it occurring out here, and these particular tombolos, these are forming as a result of wave refraction. Again, another example of a tombolo being connected to the sea. And we've got a beach in this one, sand dunes at the back of the beach. We know there's sand dunes because there's contour lines there indicating higher ground, and we have a sand spit. So lots of features of deposition. And what you're looking at in this map, this is the aerial photo of it, is it? Yes, it is. I'm just trying to, sorry. Oh yeah, so there's the tombolo forming, here's the sand spit coming out here, and here's the beach. Right, so this is what you need to know in terms of coastal deposition. You need to be able to explain the process of longshore drift. You need to be able to understand what constructive waves are and how they work. You need to be able to explain beaches and sand spits in detail with diagrams. For bars, lagoons and tombolos, you just need to be able to recognise them on OS maps and be able to say that they're formed by deposition. Okay, I am going to leave some instructions in terms of the work that I want you to do for that. I hope this is okay for you to understand. I know there's a lot in it and it's difficult doing it this way, but look, just drop me a line if you're confused, and hopefully I can try to find a way to make it better for you. Alright, thank you.